Hello students, today we are going to discuss an important topic of RDBMS, that is the Codes rule. So about Codes rule, it was invented or founded by Dr. E.F. Code, who as referred as the founder of relational database system. He defines a set of rules that were intended to define the important characteristics and capabilities of any relational system. Though it is referred to as Code's 12 rules, in reality there are 13 rules. The Code's rules are, so it was given by Code's Dr. Edgar F. Code after his extensive research on relational database management system, and he came up with 12 rules of his own, which according to him a database must obey in order to be regarded as a true relational database. Okay, so these rules are called as 12 Codes rules, but they are actually 13 in counting, because there is a rule 0 called the foundation rule also. So we are going to discuss about the rule 0, the foundation rule. It says the database must be in relational form. So what is a relational form? We must know about that. A relational form can be defined as storing the data in the database in the form of tables. So how can you store the data in the form of table? It says you can store data in the form of table as there should be a table in the database, that is a set of rows and columns in which in each cell you should store the data. Okay, so it is the relational form. So rule 0, the foundation rule, says the data must be in relational form so that the system can handle database through its relational capabilities. So it is the simplest rule, the foundation rule. Okay, the next rule, rule 1, also called as information rule. It says a database contains various information, okay, and this information must be stored in each cell of table in the form of rows and column. It says the database system, the information must be stored in each cell. Okay, the first rule says the data must be in the form of tables, relational form, and second says the in the database, if you want to store the data, that data should be stored in each cell of the table. Okay, so next rule says, if rule 0 says that you must have a table. Okay, rule 1 says you must store the data in each cell of table. Okay, then rule 2, guaranteed access rule, what it says, every atomic value. So what does it mean by atomic value? Atomic value means in each cell the data in each cell, it is referring to as atomic value. Okay, every atomic value may be accessed logically from a relational database using combination of primary key value, table name, and table column. Okay, so it says, so rule 0 says you must have a table. Rule 1 says that in that table the data should be stored in each cell. Okay, in each cell. Or the next rule says, if when you store the data, you must be able to access that data, okay, anytime, by using primary key value, table name, and table column. Okay, so the next rule, the rule 3, also called systematic treatment of null value. So what is a null value? Null value has different meanings in different scenarios in RDBMS. The null value has various meanings like missing of data, no value in a cell, okay, inappropriate information, unknown data, and primary key should not be null. Okay, these are the various meaning in RDBMS about null value. So rule 3, systematic treatment of null value, says this rule defines the systematic treatment of null value in database record. Okay, if you are encountering a null value, okay, so there should be a systematic way to encounter that null value. Okay, you cannot leave that as it is and go further away. Okay, so rule 3, there should be a systematic treatment of null value. Okay, so rule 4, also known as dynamic online catalog based on relational model, it says it represents the entire logical structure of descriptive database that must be stored online and is known as database dictionary. It authorizes user to access the database and implement a similar query language to access database. So the next rule is rule 5, comprehensive data sublanguage rule, or we can say comprehensive language rule. So it says a data can only be accessed using a language having linear syntax that supports data definition, data manipulation, and transaction management operation. Or we can say it doesn't matter how many several languages RDBMS supports, but at least user must be capable of doing some fundamental operations like defining table, asking a query, update data, set integrity constraint, authorization, and other transactions like operations. Okay, so rule 6 says view updating rule. All views updated theoretically must be practically updated by database system. So I think it's moreover easy. I don't need to explain it to you. So rule 7 says relational level operation rule. A database should follow high level relational operation such as insert, update, and delete in each level or single row. It also support union, intersection, and minus operation in database. Sorry. Or we can say the RDBMS must support insertion, updation, and deletion at a table level. Okay, the rule 8 says physical data independence rule. It says the working of database should be independent of physical storage of its data. Rule 9 is logical data independence. It says if there is a change in logical structure of database, the user view of data must not change. Okay, if we are changing the logical structure, it means we are changing something logically, or we are changing the syntax, or we are changing the data management operations. Okay, so it does not reflect to the view of the user. Okay, it says logical data independence rule. Rule 10, integrity independence rule. It says integrity constraint specific to a particular relational database must be defined in the relational data sublanguages and stored in catalog and not in the application. Or we can say integrity independence rule says the database must be capable of defining integrity rules, and they must be stored in outline catalog, and they cannot be avoided. Okay, the 11th rule, which is the distribution independence rule, it says a database should work properly regardless of its distribution across a network. The end user should not be able to see that the data is distributed over many locations. Or we can say the user should not be known that the data is stored in many locations. Okay, it doesn't matter the data is stored in cloud or in SSD type or in any other locations, or it is stored in 10 other computer memories. Okay, the user should experience a unified storage experience. Okay, so the next rule is the non-subversion rule. It says if relational system allows low level access, that low level language cannot be used to subvert or bypass the integrity rule to modify the data. This can be achieved by encryption. Or in easy language, I say if a low level procedural language is supported, it must not be able to ignore integrity and security constraint expressed in the high level relational language. Okay, that's it for the codes rule. I hope you like the video. If you like the video, please like and do subscribe the channel. Thank you so much.